Can you please repeat what you said? Big O of n? In the worst case, yes, correct. I mean, again, merge sort, we always split into either n over 2, or let's say n over 2 and n over 2 plus 1. Something like that. The difference is always it's always going to be almost equal or equal. However, with quick sort, it's not guaranteed. Okay, it's not guaranteed because we are not always splitting into half. If this number here, if the first number is 5, then we will have the sequence 1, 2, 3, 4 here, and then 6, 7, 8, 9 here, 10. So this is almost half, but this depends on the pivot. Okay, if the pivot is 1, then everything to the left is going to be empty, and then we will have 1, and everything to the right is going to be the rest of the sequence, right? Now, let's say we have a sequence, or we have a set of numbers 1, 2, 3, 4, 5, 6, 7, 8. Now, I want quick sort to have a log n to have a number of partitioning levels equal to log n. I repeat, I want to apply quick sort to a sequence of these numbers. Okay, this is a set, this is not sequence, okay, so they are not ordered. I want a sequence from these numbers, i.e. a permutation. I want a sequence such that quick sort gives me a log n number of partitioning levels. Now, what is log n partitioning levels in this case? What is the value of log n? I heard 3. Okay, so the size of the sequence is n. If I want to have log n partitioning levels, n is 8. Log 2 of 8 is log 2 of 2 to the 3, which is 3. So, can you think of a way of arranging the sequence such that I get 3 partitioning levels? So how does the sequence look like? How should it look like? Assume the pivot is always the first element. Huh? Say it again. My question again? Is this usually the time it takes you to understand the question? It's very
Be honest, you are very honest.
Okay, I'm just laughing. I mean, I don't mean it, but I just remember your midterm.
No, you don't have to remember it at all.
Yeah. Okay, the question. Give me a sequence of numbers from 1 to 8. such that the quicksort, like the one we have seen, only has log n partitioning levels. So what is the sequence in this case?
8, 7, 6.
Okay, go ahead. Okay, let me create a new note. 8,
8, 7, 6, 5, and so on.
5,
4, 3, 1.
this gives you a log n? No, this was my next question. This gives you a big O of n partitioning level, because you are going to pick 8 from 7 to 1 are going to be to the left, and nothing is going to be here. And then here you are going to pick 7. From 6 to 1 are going to be to the left, and nothing is going to be here. And then you are going to pick 6, and then 5 to 1 are going to be here, and nothing here, and so on. So this partitioning level, you have 8 as the pivot, 7 as the pivot, 6 as the pivot. You will have 5 as the pivot, 4 as the pivot, until 1 as the pivot. So how many? Yeah, 8, and the size of the input is 8, and therefore it's big O of n partitioning levels. So that was an answer to a future question. Now my current question is, what is the sequence that is going to give me 3 partitioning levels? Log n partitioning levels.
So we are assuming the pivot is 1.
We are assuming what?
The pivot is 1, right?
No, we are assuming the pivot is the first element.
3, 1, 5,
Yeah, at position 1, if that's what you mean, yeah.
3,
Huh?
5.
Okay, I would say 5 is is a better choice, because 5? 3? You think 3? Okay, let me use my rubber. 3, then 2, 1. Huh? Huh? 5? 4? 4? 5? 6? 7? 8? Okay, let's see that. So 3. We are going to have 2, 1, and then 4, 5, 6, 7, 8. That's going to be 2 and 1 and nothing. That's going to be 4 and nothing, and 5, 6, 7, 8, and then 5, nothing, 6, 7, 8. I think we have more than 3 here. So what is the idea? I mean, how does the sequence look like? I mean, how should it look like? Basically, we should always pick a pivot which is going to do what? This means the pivot that we are going to choose must always halve the sequence into 2 equal halves, right?
Yeah.
So what is the pivot which is going to divide the sequence into 2 equal halves?
The one in the header?
No, we are going to choose we said we are going to use the algorithm that we have seen. So the pivot is the first element. So what should be the first element in order to allow equal halves? Or almost equal halves? 4? So, yeah, we have 8 elements. 4? 1, 2, 3 are 3, and then 5, 6, 7, 8, 4. Yeah, it looks fine. So 4 is the first element. Okay, and then we have 3 elements here and 4 elements here. Now, so these 3 elements, we know they are 1, 2, and 3, right? So these here are 1, 2, and 3. So what should be the middle one? So we know this here, the elements here are 1, 2, and 3. So how do we order them so that we get 2, 1, 3? 2, 1, 3. 2, 1, 3. So this is 2, 1, 3. And now 5, 6, 7, 8. How do we arrange them? Seven? 7 or 6, it doesn't really matter. 6. So we will have what? 5, and we will have 7, 8. So that's what? 5, 6? No? 5, 6? No? 6, 5, 7, 8. 6, 5, 7, 8. And finally 7, 8. So that's 1 level, that's 2 levels, and that's 3 levels. Now, was that question really hard? So you were unable to solve it until I started showing you the logical thinking. So we said the logical thinking is, when I have this question is, in order to get log n level, the pivot at every level must split the sequence into 2 almost equal halves. And we can only do that if the first sequence we have the number 4 or perhaps 5 if you want. So I put 4 and I put empty subsequences and then start thinking recursively. The solution, do you understand it? Now, why were you not able to come up with that solution? Okay.
I was confused because I don't understand that I have to choose a pivot to divide it to somehow in a subset, an equal subset. So just don't get confused.
Okay. But that was the key to the answer. In order to get log n, the subsequences must be split into equal halves, and therefore the pivot must always be the middle point. But anyway, so where were we? So we have seen just now in the examples, we have seen that the number of partitioning levels in the best case is log n. In the worst case is big of n. So that's the number of partitioning levels. Now, if we go back to our algorithm, the partitioning routine, which I haven't written, I said in the naive quicksort, I said A1, A2, A3 equal partition A pivot. Okay, but I did not include the code of partition. So, how do you write partition? How do you program it? How do we do? Yeah, so we are at this stage. This is the input to partition, and this is the output. This is input to partition, and this is output to partition. So What is the code which is going to give me that?
We split the array or the elements inside the array into subsets. Bit not really polygon, right?
Yeah, but yeah, in terms of code, I mean, how are you going to do it? Yeah, but yeah, in terms of code, I mean, how are you going to do it?
We need the condition.
Yeah, for loop. So we have a for loop. Okay, so we have a for loop which is going to traverse the elements from the first one to the last one, and each time it is going to compare the element to smallest or smaller or bigger than the pivot. Yeah, and if it is smaller, the element is added to the left sequence. If it is bigger, so we have a loop. Okay, so what's the complexity of partition? Yeah, so here it's big of n. At this level, as you can see, we are partitioning this part, and we are partitioning this part as well.
Another inner loop.
Another inner loop? Why do you need another inner loop?
Because we have the first level, we have three subsets, and we another node to the first subset to show the pivot and compare between the all elements and the subsets.
For this reason, we are using recursion. Okay, for that reason we are using recursion. So it's this code, and the partition is basically saying for all elements inside the array A, if element less than pivot, then throw it in this subsequence. If it is greater, put it in this subsequence. If it is equal to the pivot, then put it in this subsequence. So this is partition, and it traverses the loop. So at this level, it costs 8 steps to traverse the loop. At this level, we are going to traverse all these steps. If this was like 5 and 4, then we have 5. We traverse 5 and traverse 4. So at every step in the partitioning, we are always having big of n of work, and then so each partitioning level is big. Each partitioning level. So each partitioning level is big of n. Give me a break. Right. So each partitioning level is big of n. And how many partitioning levels do we have? Well, we said between log n and n. Okay, the number of partitioning levels. If our choice, if we are always lucky to pick a pivot which is going to partition the sequence into equal halves, then it's big of log n. That's the best case. In the worst case, big O of n. Okay, so we have, in the best case, we have big O of n partitioning repeated big O of log n times. In the